Good evening, all. My name is Kunal Sharma. I'm in my final year of engineering. Currently, I'm pursuing my B.Tech from Electronics and Communication Engineering from LNMIIT Jaipur. So, in this video, I'll be demonstrating my project that is an antenna trainer kit. So, we'll continue with the demonstration. Welcome to the demonstration of our innovative antenna trainer kit. This system allows the user to study antenna radiation patterns with precision, featuring a transmitter section, a wide frequency range, a receiver section with an intensive range, and advanced capabilities of data visualization and storage. So let's explore its functionalities step by step. So first, it's the transmitter section. Let's talk about the transmitter section. The transmitter section is built using ADF4351 wideband synthesizer with an integrated VCO, that's voltage controlled oscillator. This powerful unit can generate signals across a frequency range of 35 MHz to 4.4 GHz. You can also set one of the four output levels from -4, -1, +2 and 5 dBm, that enabling you to test the antenna's response to varying signal strength. As you can see, currently the transmitter is set at a frequency of 2400 MHz, that's basically 2.4 GHz, and the PLL is in locked condition, and the output is at +5 dBm. Coming to the receiver section. So the receiver section featuring the LTC5596, that's linear RMS power detector. This component supports frequencies from 100 MHz to 40 GHz, allowing us to measure antenna's radiation pattern across a broad range. The detected power values are processed in real time, making it possible to plot radiation patterns with high accuracy. The additional feature of the trainer kit is it enables Bluetooth communication. Our kit supports wireless communication using a Bluetooth module, that's HC05. The transmitter and receiver data are transmitted via Bluetooth and displayed onto the GUI, developed using Visual Studio. So coming to the GUI part. So for the time being, So continuing with the GUI part. So for the time being, we are connecting the receiver and the transmitter section. The receiver section for this time is having the COM port 11 that you can see in the device manager of your system. Here is the COM port status, that's basically connected. Now coming to the transmitter section, the COM port is 18. Sometime you may come across this error, that is the semaphore timeout period. So you need to just press OK and reconnect it. So connecting the transmitter section at COM port 18. So the transmitter section is now connected. So generating a signal of 2.4 GHz and the output power level at +5 dBm is our example case. So generating signal. So the signal has been generated. As you can see, the GUI provides you the measurement controls. The measurement controls are provided for precise angle measurements and real-time polar plotting. Using the NEMA 23 stepper motor and TV6600 driver, the antenna can rotate in precise measurements, ensuring accurate measurements. The GUI plots the radiation pattern in real time as antenna rotates. So we'll be taking a real-time measurement for complete 360 degrees of rotation. As you can see, the graph is updating and it is plotting the power at real time. Currently, the configuration of the antenna is in E-plane. So the polar plot that we are plotting right now is of E-plane, the radiation pattern. As we can see, the polar plot is updating at real time. After complete 360-degree rotation, as you can see, the motor is already homed. So the antenna comes back to the initial position. That's basically the home position. Our system also allows data to be saved for further analysis in both Excel and text file. For an example point of view, we can save it to an Excel file. So I have created another folder for saving it. That's antenna trainer kit. Let's name it example 1. As you can see, once the data is saved to the Excel sheet, the notification comes onto the GUI. So user gets to know that data have been added to the Excel sheet successfully. Also, in addition to that, you can visualize the polar plot in more depth by the additional feature of polar plot. You can see there is another section where you can get in-depth insight of the polar plot with for every angle the respective power value. That's in relative. So you can save this polar plot as in the graph. Let's name it image 1. So graph image saved successfully. So user gets to know that the polar plot he plotted gets successfully saved. So the conclusion of this demonstration was our antenna trainer kit combines precision, versatility, and ease of use, making it an invaluable tool for studying antenna radiation pattern. Thank you for watching and feel free to reach out with any questions. Thank you.